In QED.NET version 11.2, we are adding a new analysis tool that provides a very useful visualization of the mid-spatial frequency features that are present in a map. The new QFit tool provides a rapid two-dimensional Q-polynomial fit to a metrology map using the methods described in Greg Forbes' 2013 paper entitled Fitting Freeform Shapes with Orthogonal Bases. So in this video, I'm going to briefly demonstrate how to use the tool. So let's jump over to this analysis scratchpad where I've loaded a circular metrology map. I'm going to search for the QFit tool in the toolbox, select the map, and click execute. So you'll see when I first try to run the tool, I get a message saying that I need to have a circular perimeter set on the map. So the easiest way to fix this up is just to run the AutoMask tool. And then run the QFit tool again. The tool generates several outputs, and 3 of them are shown by default. The Q spectrum map, which shows the magnitude of each term as a function of radial and azimuthal order. The aberration map, which shows the terms that were fit to the map. And the residual map, which shows what was not fit with the selected terms. So let's look at the Q spectrum map in more detail. By default, the tool will fit the metrology map with 20 radial orders and 40 azimuthal orders. So since the Q spectrum map has lower resolution than a typical metrology map, it's useful to use this new option to turn off interpolation to see the individual points in the map a little more clearly. For any point in this map, the horizontal axis represents the azimuthal order, and the vertical axis represents the radial order. So in the Q polynomial representation, that corresponds to M as the horizontal axis and N as the vertical axis. The example map that I loaded is a synthetic map with 24 spokes. So from the Q spectrum output, we clearly see a peak that corresponds to a particular azimuthal order. And you can see that as I move my mouse over the map, the X and Y or M and N coordinates are shown down here in the bottom left. So when I put my mouse over the peak, I see that this represents an azimuthal order of 24, as expected. So just at a glance, it's very easy to characterize the error in the map. In addition to the QFit tool, there is a corresponding Create QFit Map tool that can create a map from a set of QFit coefficients. This can be useful for filtering out certain features from a map. So down here, I have a similar map with 24 spokes, but also a lower amplitude 36 spoke feature. And so if we look at the Q spectrum map, we can clearly see that. We have one peak here at 24 and another one at 36. So if I right-click the tool and go to Show Hidden Outputs, I can display the coefficient table that shows all the coefficients for all the terms that I fit to the map. So then if I go to the Filter Table tool, I can choose to filter that down to only terms where M is equal to 36. Then I can take that filtered result and now run the Create QFit Map tool. And this effectively filters out the 36 spoke feature from my original map. So I have my map here, which was dominated by the 24 spoke feature. And using this tool, the filter table, and then the Create QFit Map tool, I was able to easily filter out the 36 spoke feature. So if you have any more questions on what this tool can do or would like more help on how to use it, please reach out to one of our applications engineers and they'd be happy to help you.